Hi, this is Chris, and we are going to take an introductory look at hydrostatics. So first let's talk about what hydrostatics are talking about. Hydro, so we think fluids. Static, we think something that's not moving. So think fluids at rest. And a fluid, even when it's at rest, is going to exert a pressure. And one of the first equations that you'll see when dealing with hydrostatics is going to be this equation that we see down here. Let's talk about what these values are. So this is going to be your hydrostatic pressure, and that's going to be your pressure at a particular point in the fluid. So basically, if you have, let's say, like a cup of water or an ocean, that fluid is going to exert some pressure throughout the fluid in every direction. And depending on your outside pressure, so this is going to be pressure at the surface of that fluid, so hydrostatic pressure and pressure at the surface, and then you're going to add on to that pressure at the surface, you're going to have a particular density of your fluid. We know G, acceleration due to gravity, and then for D, it's going to be your depth. And that's why, for example, that if you are a diver, the deeper you go in the water, the more pressure you'll experience, right? That's why deep sea vessels have to be constructed in special ways, because they're going to really large values of depth. And if this value increases enough, then the hydrostatic pressure experienced is also going to increase accordingly. So these are the values that we'll see in this equation, and this allows you to calculate a scenario like this, and we'll get into some actual calculations next. But if you have some sort of container with a liquid in it, then you can calculate, for example, the hydrostatic pressure that maybe a particular object might experience. So what is the pressure that the fluid is applying to this object? Well, they'd have to give you some numerical values, and you'd plug it into this equation and solve. Commonly, you might have the pressure at the surface equal to your atmospheric pressure of 1 atmosphere. A lot of times, if you're dealing with water, the density of water is going to be 1 gram per mil or gram per cubic centimeter. G we know, and depth is going to be measured, like for any given scenario. You'll either be solving for it or you'll be given that value. So up next, we're going to take a look at how we can do some actual calculations with this equation for hydrostatic pressure. Thanks for watching.